somewhere flash drive with all the files that you will require. I have also QCOW image for QEMU that you can use if you don't want to mess up your computer, because you will need to install about 6-7 packages on Fedora. So yeah. So the goal that we are trying to achieve across Red Hat is to share as much of tooling as possible with Fedora. That means open source anything that we can, because Fedora they have a rule that they cannot use anything which is not open source. Also, it should be published on open source, let's say, like GitHub and so on. So it shouldn't be closed source. GitHub is it's not fully open source as far as I know. So it should be on Azure and so on. So the list of upstream projects that I selected is not the biggest one. I think that we have about, let's say, 5 times more. But these are the ones that I think that matters as far as Linux distribution goes, because we are building also some JBoss products and so on. Koji, who hasn't heard about Koji? No, I don't believe it. So Koji is a build system that we are using in Red Hat, also in Fedora project. I don't know about any other bigger projects, maybe you guys know, but I don't think that CentOS is using it. However, this tool is, basically, if I will tell you that there is nothing that we should publish to customers that wasn't built in Koji, I think that I would be right. So if you have the presentation, all of these should be links, which will take you to the project site or some demos. So this is how it looks like. I don't want to go through the whole Koji because that would be for 2 hours. So basically think of it about build system, and it's also a tool which enables you to execute remotely commands. Let's say that you would like to build your own distribution on all of architecture. Architecture is not just the one that's on, let's say, your laptop. So you might use Koji to run some commands on different hosts based on inputs. Could be anything which is registered as host within the system. Remote execution is called basically run root. So if you are interested in build systems, if you think that you might need one for the company, definitely look at the project. I'm not using it in this demo because using the build system would require to have all the packages required for the build, and so in the build system that would take several gigabytes, and my tarball has only 50 megs. So my source of packages is actually a repository, not the build system. The good thing about Koji is that everything that you build in Koji should be reproducible. There are time events in history, and you can be sure that if you will resubmit the build, it will use exactly the same build root. Set of packages used for building the package should be exactly the same. Also, within the company, we are using Koji as a storage and linking all the packages that has been built and stored in Koji to, let's say, composes, repositories, and so on. So if you would have any questions, ask, but I don't want to spend much time on going through each project. So Punji, this will be the main actually tool in the demo that I would like to show you. I would call it a compose tool. If nobody knows what compose is, I would probably call it a set of repositories, images, ISOs, basically deliverables, somehow connected through metadata. So you can process metadata, and you can iterate over all of these things that you are building. Could be RPMs, ISOs, Docker images, and so on. Product MD. So I've mentioned metadata, and you don't want to parse JSONs on your own. So we have a library for parsing all of the metadata that's being used in Compose. So don't try to write something new. It never works. All of these projects are actually hosted either on GitHub. So this one is, for example, on GitHub. Some of them are on Azure, like Punji. Also, we would be so happy if you will try the tooling, it will fail for some reason. Just don't throw it away. Report issue. Hey, I was running this. It failed. Trace back, whatever. Just submit whatever you can. It's really helping because we are using our tools in a very specific way, and we are probably not going to change the way how we are using it. So you guys will have different use cases, and it might just not work for you. PDC. Has anybody heard of PDC? Oh, awesome. More than I thought. So PDC is Product Definition Center. So again, release engineering is using the tool in a different way than quality assurance and so on. So I will talk on behalf of release engineering. So I've told you that we have Compose, which is a set of repositories, ISO files, Docker images, bootable images, and we have metadata, but it's just some JSON locally. It does have API through the ProductMD, the library for parsing the metadata. However, it's usually stored on the destination, which is not accessible to everyone. And PDC, for me at least, is let's say a service which is storing all of these metadata. You can basically filter them. It has a huge big API that you can use, and it's very comfortable to use. So Luboš actually told me that Fedora project has a testing instance. I don't think that it's fully populated, but it might give you some opinion about how it could look like. So how we track things in PDC is that you have product, for example Fedora, then you have release like Fedora 24, and this release is linking composes, which are sets of repositories, and each compose has basically subsections, RPMs, images, and you can basically see everything which was built inside the compose in PDC. Could be used for CI. CI can just listen, hey, new compose was imported. Let me see if there was a Docker image. Yes, there was a Docker image. What's the metadata for the Docker image, and they can decide whether they want to test it or not. Yeah. So this is quite useful actually. Nice. Oh, sorry guys, wrong link. It's not all, definitely not. So let me go for the here. Will it work? Click PDC? No, okay, so HTML5 is beautiful, but I'm not sure if it's always useful. Oh, back, PDC. So basically we have a compose, set of RPMs, images. We have metadata. We've already imported it into PDC. Now we would like to publish it to customers. It doesn't have to be, external customer. It can be team within your company. So PDC can also store mappings. Let's say that all the RPMs from this section of compose goes to this location. So you can basically store all of these mappings, and then you can use, for example, Pulp to distribute them. So internally at Red Hat, we have a layer in between them. There is another tooling which is basically parsing the data from PDC, and then we are actually creating some sort of transformation above compose and pushing it to individual delivery channels. They can be FTP, it can be RHN, it can be so many other services, you name it. And Pulp is basically a repository manager that we are using. It's also being used in one of our products. So I believe that Fedora might actually consider to use it as well. I don't think that they decided. Just saying that it's out there, it's open sourced, it's actually originally from Red Hat. Feel free to use it. I'm not using it in this demo, that would be so much overkill. And I think that's all about it. Coffee break, no, I think that we went through it quite fast actually. So, but if anybody would like a coffee, I would like to move to the more like the technical part with the demo. So it might actually take some time to get the tarballs with the data. So guys, if anybody wants coffee, I think it's the right time. If you are all set, it's even better. So does everybody have internet connection? And how many of you actually have Fedora? Because I have a virtual, awesome. So those of you who want to try it, there is a 50 megabytes tarball. You can just download it. You will have to install packages like yamutils, create repo, and these are actually basically used for creating repositories. And the tooling that is actually located in tarball requires them. So if you don't want to mess up your computer, feel free to use the QCOW image. It's working. I was testing it today. It's on my flash drive, so or here as well. So just ask for it. So let me stream it on the screen actually. So are you downloading it?
Still downloading.
Sure. I will wait. No worries. Yeah, Flash. I have actually Tarball here. If you want to borrow it, it will be much faster. Just pass it over. So the presentation is called, I believe, Building Distribution the Red Hat Way, while the data is called DevConf 2016. So use the DevConf one. So I was thinking of a small package set that would be like 50 packages, and the deb solving would be complete. And I was thinking of distribution which consists of 3 different shells: Bash, Korn shell, and Z shell. So there is a setup which allows you to build distribution, including all of the dependencies. So it's not going to be bootable distribution, definitely, because that would require Anaconda and a few other things. However, if you will iterate through the configs, you can basically build it up to the bootable distribution. However, it does have ISO files. So yeah. So if somebody would be actually looking for the Tarbos, people Red Hat command, yeah, it's here. I know. So wait for the flash drive. I'll wait a few more minutes. Meanwhile, I can just get my desktop ready. Would be maybe cool to show you our Azure. What sort of projects do we have? So as far as release engineering goes on Azure, Azure is basically open source version of I would say source control management web UI system, something like GitHub or SourceForge. It's quite new actually. Developers are from Red Hat. They are super responsive. If you have some issue, it doesn't work. It was really like crappy from the beginning, and each issue that I filed was solved in one day. It was really awesome experience. So the tool that we are going to use is called Punji. It's the Compose tool. It's located on Azure under Punji. Feel free to check it out. We have documentation, sort of. It's more likely a RST with example configuration. This is for Fedora, I would say. Yep, definitely. Oh, here. Cool. So one thing, the Punji itself can actually gather data from multiple locations. One of them can be the build system that I was talking about, Koji. So as I said, Koji would be overhead. It would be a few additional gigabytes in the tarball. So I decided to use just the repository with set of images. Repo closure should pass on them, as far as I remember. Otherwise you can easily use Koji. If you are using just the local environment, you are actually lacking run root, so you can only run it on the native architecture of your host. But for this purpose, it will be sufficient, I would say. So oh. Dá se to nějak vycentrovat ten obraz? Asi ne, co? Okay. So you guys have to imagine the very first character because it's not fully visible. Yeah, but then it won't be full screen. Yeah, could work as well. So this is the README file. Oh. No. So install requirements, basically you can see that it's create repo C, Pi kickstart, Linux utils, ISO, MD5 sum, because we are producing ISO files for DVDs. Punji can create both bootable images and non-bootable images. So the Kobo here is set of wrappers. We are using so many functions from it. It's also open sourced. So as I said, what I would like to achieve is to create some sort of distribution with ISO files. It will have just the shells plus dependencies. You have full control on config files. You can add some more packages if you can generate some fake ones. Yesterday I was thinking whether to generate 1000 of some fake packages from dictionary or just take something which makes sense. So for me, shells were quite small. Everybody set? Also, I believe the flash drive has also bootable image. Yep. So if you are using bootable image, you will just boot into Fedora, which already has it under root. So what I would like to go through, and what I believe is the main goal, is to show you how to use it, tell you all the features what the Compose can actually, Punji can actually generate, because it's not just RPMs, it's not just ISOs, it's so much more. And I believe that it can be useful for people who are building distribution and they might not even think of what everything should be inside. So this tooling is currently being used to build Red Hat Enterprise Linux 5, 6, 7. Also, for so many other layered products. Layered product is something that you install on top of other product. So we are all set for layered products as well. Of course, we are stuck on different versions of the Punji across the company, and we can't change it, during the product lifecycle. So the code base is a little bit different, but this is the newest one. If you would have any problems with the tarball, just let me know. I have it all locally. It takes a few seconds to generate new one with fixes. Also, the tarball is basically a Git repository, so if you would feel like you messed something up, just reset it to head and it should be clean. You can start again. Those of you who already have the tarball extracted, feel free to read the README file. You might actually want to go to conf directory, which hosts basically all of the configuration. As I said, it should be... Yep. So the default paths are root devconf, because I created the tarball for the QCal image, actually, which is only having root user. So the first thing that you will have to do is to change these two paths to your location where the directory is, and that should be all. So we are still waiting for a few guys. Let me quickly go through the config file. I will go through it once more once everybody's set up. So this is probably the very minimal config that you can come with. I call the release devconf Linux, so I think it matches the purpose. Release short, this is basically the string that will appear on ISO files as far as file names goes. Also, the directory structure will use devconf inside the name. Is layered, this is basically whether you are building product which is supposed to be on the bare metal, or you are actually building a product which is supposed to be on top of another product. Bootable, false, we can't really boot bash. Comps files, this is an XML, which is basically setting the building blocks for the whole compose. So you can say, my product is going to consist of variant called, let's say, Fedora workstation, and the Fedora workstation will consist of several groups. Let's call it core, network utils, network services, web server. So and these, web server is going to consist of HTTPD and a few others, and you can iterate like this. And this is basically all defined in single or multiple XML files within, we call it comps. It's also being held in repo data as package groups, basically. It can be either SCM or the file locally. I just found another bug, which is kind of, it will fail if you will use just the path instead of the SCM dictionary. So please use Git. In this case, we'll fix it. There's a guy who will probably fix it. He's responsible for it. Variants files. So basically, comps is just grouping the set of packages. Let's call it web server, let's say SQL server, core, I'm just thinking network services and so on. And the variants is actually grouping them inside into variants. So let's say variant server will consist of 24 comps groups. So the variants is actually defining like a more abstract layer above the comps groups. SIG keys. So if you are building RPMs for your company, or if you are working on some product, you might know that these RPMs are being signed with some key, which is identifying you as a vendor. So SIG keys is set of keys with priority from left to right. So none means that you allow unsigned RPMs to be inside your distribution. You shouldn't do it on production. It should be always signed, ideally. If you are doing something internal only, it can be unsigned. 3 architectures. As I said, we are not using build system or Koji. This means that we can run only on native architecture. Basically, this is going to be the host that I'm going to use, so it's only Intel. We can do also 32-bit. I decided not to. If you are using 32-bit and 64-bit, you can decide to use multilib. Does everybody know what multilib means as far as distribution goes? That means shipping RPMs of multiple architectures. Usually we call it primary, secondary. So in 64-bit, it would mean that, for example, you are shipping both 32-bit and 64-bit Firefox or some libraries. Because as far, maybe you remember back in days when you were actually supposed to use Flash Player on Linux, it was only 32-bit, so you have to have all the libraries, on your 64-bit systems, and they had to be 32-bit as well. So we are actually covering these scenarios as well. Java is so typical, you might actually need to run 32-bit Java on 64-bit machine. So if you decide to use multilib, it will put basically, these 32-bit packages into 64-bit repositories. So I left it empty. Run root, this is the remote execution of commands. So let's say that you would like to run make on a non-native architecture. So you would call something like Koji run root P means a package which would be installed. Let's say that for make we would probably need, I think it's make utils, and M would be some file system that you might actually need to be mounted in some sort of run root. It's all inside root, so you might actually need to mount Koji, and then there is the actual use shell, so you can actually use string instead of a dictionary, instead of list, and use shell, and then you would just do whatever you need to execute, like, I don't know, echo hello. And it would be just executed, and you could collect the results afterwards. It would be probably stored somewhere on the mount Koji. So this is how we are using remote execution. So the best approach is if everything is tasking in the build system, whether you are creating repository or building an ISO file, it should be tasked. If it's not tasked, then we are using run root. I think that tasks are much more elegant because they have defined API, and it's not something that you are writing by your own. So this is the run root. package set source, so it should be either Koji, the build system, or the repositories, which means that you have some storage with all the RPMs, and you are reading it from the RPMs. So package set repos, this is basically the source for individual architectures. So you can see that the x86-64 is going to be located in my home directory. So inside this test data, sorry, can't see it. Inside this test data, there is actually just directory with RPMs and repo data, and we are actually using it as the source for our distribution. You can set multiple ones. Just read the documentation. Everything is described in there. So these are specific only if you are using the build system. So we are not. So let's just have them commented. Get resource. Comps. Comps means that we are actually reading the building blocks of our distribution from the comps XML file. It can be as well none. And then you can use a section below. It's called additional packages. And you can just say, hey, server variant consists of these and these and these packages. And you can completely skip comps groups. So it allows you, I think it's more flexible, but it's more hackish because you can create something that nobody else will be able to read, several conditions. So I would always recommend you to use some valid file like XML that can be validated, everything, and to use sections below that I will show you only in corner cases when you need some exception that it's not, achievable through comps files. I'm not sure if I should show you, like our internal configuration files, but it's messy as long as you are joining the dark side. So create repo C, that means whether you are using create repo or the new create repo C. I believe that the old create repo was written in Python. Performance difference is huge, so we are using the create repo C. Build install method, this is basically let's say you can tweak Anaconda to a product specific, let's say, no, that's the product image, sorry. So build install is basically, a phase which generates a bootable image. So create ISO section, this is related to optional. Let's not talk about this here, maybe later, because our demo doesn't cover that and it would be so much additional logic. Multi-lib blacklist. So I've told you that you might actually decide that you would like to ship 32-bit packages on 64-bit system. Blacklist is basically also these multi-lib packages are being, the decision making is in some logic. We have several approaches. One is that you might actually decide to keep only libraries to be multi-lib, or you can set that you can say you would like to have all multi-lib by default. Or you might just set some exceptions that should be multi-lib and the rest will be just 64-bit, let's say. So you have blacklist for it, you have whitelist. I think that they are it's pretty much clear. You can either say this package shouldn't be multi-lib or this package should be multi-lib. Additional packages. This is a section that you can basically use either on top of comps or without them. So you can decide whether you would like to add some specific packages that are not listed in comps groups into some sections of your compose. Filter packages is the exact opposite. You can just say that these packages shouldn't be on these sections. And yeah, we won't really use product IDs for our product, and this doesn't make sense unless you are actually building Koji, Docker images. So I would say let's launch the script and let's go through all of the outputs that the script actually generated, and then probably most of this configuration file will make sense. So if you will go to the DevConf 2016 directory, there is a README. Always read README before running anything. You should have these dependencies installed. They might be called different if you are using, let's say, RHEL 7 or CentOS or some other distribution. So if you are, then my recommendation is to iterate through executions and install whatever is missing until it will be installed. And let's just run me.sh. Yeah, also a good thing would be probably to show you the comps files that I've mentioned. conf comps. So I basically told you that we are building a product which consists of shells plus dependencies. So here is the definition of group shells. You can have multiple groups. For example, if you would like to create web server, you would have the same group, similar group, but with different packages. So you are supposed to set only the base packages that really matters as far as your distribution goes. All the dependencies will be gathered automatically. And then the variants file, which is basically saying, hey, we have variant called core, just coincidence. And this consists of these architectures. Each variant can be supported on different architectures. So you can have server, which is for PPC, and then you can have client, which is only for x86-64, if that makes sense to you. And our core variant consists of a single group called shells. So basically you can create also variant inside the variant, and then we have something called integrated layered product, which can be just a single thing that you can install on top of basically anything. It doesn't have to be variant specific. Okay? So basically, what this is saying is that our compose is going to have variant core, and the variant core is going to consist of shells, which are defined in the comps group, right? So so let's actually see how it looks like. So if I'll use browser because I believe it will be much more defconf 2016 trees. So here we go. So basically, if your script went right, I'm not sure if you guys executed it, hopefully yes, and it finished, you should have structure trees under the defconf directory, and this will consist of one or more composes. You can run it as many times as you want. It will just iterate, it will create new directory, and it will create new symlink pointing to the latest one. Okay? So each compose has some sort of compose ID, which is created by merging the product or release short, which is defined in the Punji conf that you guys seen, plus the timestamp, right? And the 1 in the end means that it's the, basically, first you have 0, 1 is the second iteration, and so on. The n actually means that it's nightly. Each compose can have type. It can be either production, which basically tells, hey, this distribution build is marked as production. Otherwise, this is just some testing compose. So n is basically, saying, hey, this is just this testing compose being run on nightly basis. Status finished. If it's finished, all is set. Can be doomed as well. That means that something got broken, or it can be running. So if it's broken, Punji actually allows you to, let's say, repeat some specific phases. Like you might not actually want to rerun create repo on all the packages if you know that only ISO file creation failed. Then you might as well consider rerunning just the ISO file and see what was wrong. So Punji runs everything in phases. I will show you after I will go through the whole structure how it looks like. And the actual tree structure is in the directory called compose. As I said, compose has metadata. These metadata are created by productmd. You can read them again by using productmd. It's basically very simple. It should actually tell you the directories for all the, let's say, packages that you have in your distribution. So in our case, it's just core. You can have debug packages, ISO files, Jigdo files. And we know that it's only x86-64. So this should be a list of all images. So as I said, this compose is going to produce ISO files. They are not bootable because shells are not bootable. And here is basically some metadata for the image. So in ideal case, you would just take this metadata and you would upload it to the PDC, which I already spoke about. It's definitely better than just, relying on some files that can be actually deleted by some cleanups. At least they have some history. And RPMs, this is basically JSON with all of RPMs which are located in the compose. As you can see, structure, its variant, architecture, and then SRPM, and then the binary RPMs which were created from the SRPM. So as long as you are using product MD, you can easily iterate through it.
And it will all those extra packages because of the dependencies of those 3 shells.
Exactly. And I'm going to show you how it was actually generated, I mean the dependency tree. So there are several methods. You can say either gather all the dependencies, or you can just skip them, and or you can say just include everything which is in the repository. So it's different approaches, you can configure it. So I believe that here, if I would look into configuration file, you would see that we are using the comps, and getter method is deps. This means gather all the dependencies as well. It can be none, then it means that, hey, don't take the dependencies. Might actually make some sense. For example, if you have layered product, which is, let's say, being installed on top of Fedora, and the layered product is somehow expecting that it shouldn't contain the same packages which are already on Fedora, you can set something which is called look-aside repository. And this is saying, hey, if some of these dependencies that this package in my comps group requires are present in this repository, just don't include them because we already, they are part of different product, if that makes sense. So you can also set some, I think it's here. I've seen a hand there. So what was the question?
What happens if there are multiple versions?
Yeah. So the greedy method actually built here. If I will show you the source, we have plenty of time, so yeah, let's do it. The greedy method, or the method, is actually saying, let's show it. There are several approaches. One is called best match. So basically, it will take the one which is matching the best, while it will be the newest one with all provides that you need. And I think it's alphabetically sorted actually. So if you have multiple versions, if you are using the build system, and build system is linking packages into tags, and tag can reflect only a single version of package in time, then it's super simple. You have always the version which in Koji or build system terms says, if you tag the package the last one into the tag, it will be always the version. It doesn't matter that the version is older or newer, it's just the timestamp when it was actually somehow tagged into the system. So if you are using repository as source of data, that's kind of risky, and you are right. It will the method will take the best match, but it doesn't mean that it's the package that you really wanted. Okay. So as far as build system goes, it's super clear, and there is, let's say, if you would like to see, if you would run Fedora compose, and you would like to see what version of bash there is going to be, it's going to be this version. And it's super, there is strict rule and you can't go over it. If you would like to see all the versions which are in the build system, see? So it's really a matter of which one was actually tagged. The latest tagged usually means build, basically, because the tag is an operation which is being done on after each build. You can say, hey, if I'm building this package from this branch in Git, it's going to be tagged with this tag. Let's call it F24, for example, which is representing your distribution. Okay. So, yeah. So greedy method. Yeah, I wanted to show how it looks like, because the good thing on the Turbo is that you have actually sources of all of the tools that we are using here. There is also a method which, if you have multiple versions, it will just drag them all, which might be behavior that you are actually. See? None means only best match package. All means all packages matching a provide that you've mentioned. So provide is basically the record that you've set in comps. If you are looking for system release, and there are several packages providing system release, like Fedora release Workstation, Fedora release Server. If you will set none, it will be the best matching one. As far as system release packages goes, there is ugly hack inside Punji, which is always checking the name of the variant, name of the system release package. So this is something that we would like to remove. Also, if you would use all, that means that it will include all packages matching the provide, which will be all the versions that could be in the repository. And build is the best match plus its dependencies, which is what we are using here. Okay. It also includes, if you have SRPM, let's say that you want only bash, but bash SRPM actually results into several RPMs. It's bash documentation, probably bash man pages, and so on. So if you are using the build greedy method, it's going to include also rest of the RPMs which are located or created from the same SRPM as your requires. So in this case, bash doc should be part of the compose even when we didn't really ask for it, and it's not really dependency of bash. This can be useful because, at least how we are building rel, if you really want to include single RPM from SRPM, you as well want to include all of the rest. They might not be supported, they might be delivered in a different way, but there will be part of the compose. Okay? So, yeah, let's go to here. So as you can see, our compose consists of all of these packages, which are basically dependencies. And there was a question about dependencies, if it's going to include them or not. So Punji, the binary that I've been executing, it's called actually Punji Koji. And the Punji is just a tool which generates you dependencies and creates a single repository based on the inputs. Let me show you how it looks like, because it's really, I think this is the base stone of the whole tooling. So if you will go to the root of the compose directory, there is a directory called work, Punji. Here is the configuration, which is basically group shells, which is defined in the comps file that you've seen. So it consists of KSH, bash, and ZSH. Fedora releases edit automatically. This is a logic of Punji, which I dislike. And I would like to see it removed, but it is what it is. And here is the log. So Punji is actually saying, hey, I just found definition of Z shell or provide. I found these, Corn shell and bash as well. And let's just include them into the distribution. I am skipping the SRPMs, so ignore the SRPM messages, because if I would like to include also all of the build dependencies, it would be huge. So here you can see that edit glibc because bash requires it, edit ncrc libs because bash requires it. So this is the way how the Punji is actually getting all of the dependencies. So it's not the compose tool itself, it's a binary from the same package. It's called Punji, and the compose tool is called Punji Koji. I know it's really tricky, and I don't know why did they pick it up, but it is what it is. So if you are looking, hey, why the hell was ncrc libs included in my compose? So you might as well, see it, edit ncrc because of, blah, blah, blah. So here it's because of bash, right? So that's really useful, because if you are trying to get rid of some additional dependencies and you are saying, hey, why the hell did I get Firefox in, compose with only shells? So you'll see why was it. You may consider actually dropping the dependency from spec file if it doesn't make sense, and you can shrink your distribution to minimum. So this is the Punji. I've also told you that it's going to produce DVD. So this is just the work directory, sorry. So we should go back to compose. Core. See, and the DVD is here. As I said, it's marked in metadata, so if you would like to see all the ISO files for variant core, you can just iterate through the JSON, through productmd. Super simple. So, I've said that I would like to go through how Punji works, and I've told you that it has several phases. If something goes wrong, you might turn on the debug mode, and you can repeat just some specific phase. So yeah, let's go into trees. And let's simulate that our compose failed. Yeah, there is one thing. There is a security, let's say, check whether if your compose was finished successfully, it prevents you from rerunning it again. And there is a message which is saying dangerous. The data is going to be unsupported, so it's really used only for debugging purposes, and you shouldn't destroy your working compose, which is working just fine. So let's put doomed into the status. Let's remove the. Are we still okay with time? I hope so. Let's remove the ISO file. Let's say that something failed. I don't know, either dependency issue or so. Or you can do RM. Yep. I think that the unsupported probably will mean in this case that our image manifest JSON will be completely broken after this change, but still you can debug what was wrong and so on. So if you would like to do some debugging, there is actually env.sh, which is setting your environment, because these tools are not being installed, they won't be part of your paths and so on. Source env.sh, Punji, Koji, which is the compose tool. Punji is just the method, gather or whatever. So Punji Koji, help, what does it offer? So we have a debug mode. We might want to set compose there. This is going to be trees, defconf. Yeah, at least you can see on which project I'm working on. And you need to set config, which you would like to process actually. So this is going to be conf, Punji conf in our case. And you might want to say just phase, create ISO. One good thing, if you will skip debug mode, it will rerun everything. So always keep in mind that you want the debug mode. Also, it specifically tells you dangerous. So Punji debug mode compose there conf. Yep, and nightly of course. Critical. Checksums must not be blank. Oh, so I think this is a bug actually. Okay, so it should be working. Maybe let's try different phase. Let's try create repo. Nice. That's why it's called dangerous, guys. So if I would do also just phase and just phase init, I think it should actually work it out. Okay, nice. Okay, so let's just keep rerunning composes, or we can debug it and we can fix it and submit patch, which would be ultimate, I would say, goal of this presentation. Yeah, so what to do in case that something like this actually happened on your system. So this is like real life scenario. Punji issues, new issue. Running, great, taking some phase results into traceback. Right, cool. And description. Okay, compose and this. Let's go for traceback, but I would like to have again the create ISO. Oh, let's just upload the traceback file. Workspace, DevConf 2016, trees. One question. Do you know why I'm not using latest in this case? I know it would be working, but in real life, if you would have multiple composes, latest is always symlinked to the last working one. So you want to be sure that you are actually touching the one that really failed. Global. How come it's not there? Image. Yeah, image fast. Okay. Wonder what I was doing last time. Global. Punji traceback. So what really happened? JSON couldn't be decoded. So it really resulted into invalid JSON, right? Let's see what was actually compose metadata images JSON. Ah, there you go. So if you do like I'll still need to have some metadata. So what about to remove it? Bang. So yep, something like that. And it will be fixed. So this is the real life scenario. This is the profit. So it's in this case. Oh yeah, I think that the traceback would be enough. So in this case, you can see that rerunning actually resulted into empty file instead of empty JSON. So there is definitely a code that needs to be fixed. So if you want to play with the compose, I think that I have some scenario for you, which would be not so easy to achieve if you are, looking for challenges. So if you would like to do a deep dive into config files and you are really interested into it, so there is a bash doc file, RPM, and I would like to make it in a separate variant, which won't be called, or separate group, and it won't be called shells, but it's going to be called shell documentation. And it will consist only these documentation files. It would be quite easy to achieve if you want to play with it. If you don't, I can again go through the phases of the compose, because I've already promised you that I am going to do that. But meanwhile, feel free to play with configuration. If you will go into test data, 2016, there is a bunch of RPMs which is waiting for you. Right? Feel free to create whatever configurations you want. If it's going to fail, just report new issue. It will be awesome. Otherwise, let's go through the actual code. Hey, this is the original owner, or the creator of the tool. Just found a bug. Daniel, just found a bug. If you will rerun compose in Punji. Yeah, if you will rerun, yeah, exactly. See, that's what I told you. So, just to repeat for him, what we've done is that we went through a list of tools that we've open sourced, which somehow makes sense for a Linux distribution. And we just did some testing compose with several shells, bash, corn shell, and so on. And we did some rerunning, and it failed. So I've told you that the Punji actually runs things in phases, and as you know, you've seen the failure that we've had, and you've seen that we've actually decided to rerun just one phase, which is the create ISO. So basically, if you will go here, you can actually see all of the phases which we have. So each phase is represented by a Python module, I would say. If you need to add some deliverable like atomic trees, which are actually requested in Pazure already, and they are quite, I don't want to say urgent, but they are. So feel free to submit either RFE or just implement new feature. It's really welcome. And so you can see package set, which is basically, I believe, getting the basic package set for distribution, right? Build install phase, which is doing the build images, gather phase, which is gathering all the depths, extra files. You guys might need some README file or some non-RPM content on DVD, like documentation, release notes. So these are actually defined in section in config file called extra files. Source can be either a Git repository, it can be partial content of RPM, for example, some man pages or whatever, or some images from, let's say, in our case, Fedora logos. You have create repo phase, which is creating the actual repositories, product image, which is creating basically product-specific installer image, create ISO phase, which is the phase which is responsible for creating images, right? Not the boot image, which is in the build install, but all of the DVDs that, like the DVD that we've just created. Live images, if you want to have some live images, we don't in this case, it wouldn't make sense. Image build phase, this is for Docker, QCow images. What else do we have in image build? I believe appliance images as well. Image checksum phase, this is calculating all of the checksums in the end of all ISO files images that you have. And it's storing them in the image manifest, which then you, in ideal case, would import into PDC, right? And pass it to CI for testing. And test phase, this is just running repo closures on the repositories if everything was fine. I believe the behavior is that if some dependencies were not satisfied, it's not going to fail. It's going to write errors in the logs, which can be produced again by QE, and that's it. So these are the phases. If you want to create a new one, you would just write a few lines here. If you will go into source code, it's quite nicely structured actually. And basically all of these files are representing phases. You can see that creating, for example, this is Docker image phase. It's not that long. So I don't know, 200 lines, 250 lines. So would you like to go through some configurations that you might actually want to achieve, or if in your head you have some solution which you are not sure if Punji would be able to cover? I think that some people might have such questions. Feel free to ask. We can go through it. We can try to map it. As I was already talking about variants. In our case, we've had single variant called core. You might have a variant called server client. It can consist of several groups. You might actually have some additional repositories for client. Let's call it, for example, web server module. And that can consist of different packages. And then you can have something called integrated layers product, which might be variant less specific, so it can be used on any variant. So I think that somebody here said that he was working on his own distribution. I'm not sure if it was gentleman here or somebody on the right side. Somebody was raising hand when I was asking who was already building his own distribution. Oh yeah, sure. So I have few scarves here, and I would like to really share them with you. So
One question. This drive tool, if they have some internal packages which depend on like the util extra packages.
sure.
And I only want to pick out the dependencies and then create a repository of that. Currently we do this manually.
Mhm.
We don't use satellite.
So,
But would this be a good
Sure.
gathering?
sure.
Or is
As
it
fa-
bad use of
I would say that if you would use it just to create repositories and not for distribution, then it's the right tool. You said that you are not taking these dependencies, or you are including them as well.
Yeah, we're including the dependencies. We don't want the full people available, so we
Exactly,
do
exactly.
this manually.
Sure. Well, what you can say is, for example, if you would have just scenario that you want just some dependencies and not the others. So, and if you are using the EPL, you can set EPL as the look aside repository, for example, and you can say, hey, just don't include anything which is already in there, and include just the dependencies which are not in EPL. That could actually work for you. Yeah, I would say that it's the right tool.
Actually, I have something else to say to that. This is still not official part of Punji. That's kind of part of my development repository, which is probably something like the next generation of Punji based on DNF rather than YAM.
Mhm.
And I've got a script there that basically can take multiple repositories and do all the dev solving and just print the results. So if you're looking for something that would gather the dependencies without all the big overhead, which is part of Punji,
Mhm.
because you're basically building a distribution rather than a simple repo, then you can use the script. So you can find the repository on Azure.
Yeah.
If you need it, or just ask for more details.
Yep.
After the
So,
presentation is over.
Is it in your private branch, or?
Yeah, it's my private.
Mhm. So in this case, his name is Daniel. You can go to pazure.io/Punji, go for forks. Just see Daniel here. Let's look at his fork
And actually, you need to switch to the
branch. Yeah.
DNF branch. Gather underscore DNF.
This one, right?
And in the bin directory, there is.
I'm not sure if we are actually able to go too fast under different branch here.
You can. As you can see, the branch is listed.
Yeah, okay. So there is gather DNF bin, right?
Yeah.
Punji gather, I guess.
Yeah, I think that's it.
So as Daniel said, that seems like basically slimmed down Punji, which doesn't do that overhead and just prints you the dependencies, right? I believe.
It only prints the package set.
Yep.
The resulting package set, and it can obviously work on Python level if you're interested in some structures and
Mhm.
details. You can use that directly as a
It's quite
Python
short, actually.
rather than command line.
Oh, yeah.
You get all the details if needed.
It would be nice if it would result into some JSON file, for example, that you can process. Yep. So whatever is your use case, you can have it covered here. You can call the function which is going to return you the packages, or if you want the repo creation as well, you can use whole Punji. I can see some use case with this script actually. Also, I don't know, I didn't want to mention it here, but basically below build system we have additional layer called dist-git, which is management of Git repositories, and there are some conditions under which you can actually commit or you may not commit to the repository, like you need to have approved Bugzilla in order to do some fix. And I've seen that release engineering on GitHub, it was good luck actually that we were able to acquire release engineering. There is dist-git, which is the same name of tooling that we are using internally. I just checked it and it looks a little bit different. and I'm not sure what's the stage of it, but you might consider having a look at it if you are looking for some solution inside the company for, let's say, some detailed level access to Git repositories as far as commit policy goes. It might be a nice place to look at it, so you don't have to create something on your own. You might just use like GitHub fork, right, and use some moderators, but this is giving you more powerful rules and conditions under which you can actually commit into repository, or you might not. I've seen some graphs how it works here. So client would be developer, right? You have a local Git, you have this Git server. Basically, you can cook anything locally, but you can commit it under some conditions, like your commit message needs to, reference some bug and so on. So I'm not sure what's the state, but it looks it's well documented, so feel free to check it out. That's something that I wasn't aware of actually until yesterday. There are also several projects. Some of them are actually related to Maven and so on. However, I wasn't mentioning them because Maven is not necessarily the deliverable that you are actually looking at as far as Linux distribution goes. By the way, if you are actually, if you are interested in the build system, which I believe is really advanced, then you might just use it in the company, especially if you are interested in reproducible builds, which might be critical. There are several tools which allows you to do some testing instance in a few minutes, because last time when I was setting it up from the scratch, it took me a week, which is terrible. And these scripts will really do it in a few minutes. One of them is Koji. I just tested it yesterday, it's not working. So the code is not really current, but I believe that we have a solution which is generating Docker images for the build system. So you might just going to check it and it should work. I haven't seen it here in release engineering. This is Pulp, this is different. Koji Dojo. Docker images for testing services that need to talk to Koji. That could be it, I believe. Image nodes, yes, sure. So it looks like it's basically a Koji image that you can use. So as I said, Punji can have multiple input sources. One of them could be a repository. This is what we used, or you can use whole build system. Then basically the input for the Koji would be for Punji would be the tag, which is holding. If you do list tags or Koji list tags, you can see all the tags with Fedora. Sorry. Full screen and you can't see it. So basically there is a whole history of Fedora, so if you would like to see what was the latest package in Fedora 19, you can easily search it here. So the compose then is just taking the image, the tag, and the tag consists of, let's say, thousands of builds, and it's just iterating through all of them instead of the repository. And then the Punji is actually linking the file instead of copying it as in this case. Because Koji is actually having its own structure with data, and if you are, let's say, if you are really picky about saving space, then linking is the best choice, I believe. If the file system with packages is well protected, it's probably the best solution that you can do. So if you would be interested about, like what packages are actually stored in the tag, it's going to be huge. But as I said, it's one of the options. For a small company, it might actually make sense to use repository instead of build system. For a company which is really worried about reproducibility and security, build system is way to go. And the integration is really seamless. No, it's going to take a long time, yeah. Thousands and thousands of packages. Just saying, if you all try it at home, it will be probably much faster. So, any questions? There was a question, and I believe it was a good point, so I think that you deserve a scarf. There you go. You're welcome. Any other questions? Or some issues on Pachura? It will be even better.
You mentioned that
Yes. Yes, we can build. It's part of the image build. So if you will check image factory project, Koji, we have implementation which supports basically anything within the image factory. So basically, our implementation is. Let me show you some example. Oh, here is the configuration RST. So the section here is saying for variant server, consider that Fedora server in this case, we would like to have Docker file, which is going to have suffix, the format is going to be Docker, suffix is going to be this one. The reason why I'm actually putting suffix as well is that single task can result into, let's say, 20 images, and these images will have all different suffixes, and this is a way to map them, because unfortunately Koji doesn't provide any metadata which would say this is Docker, this is QCOW. It's just output of single task. There is definitely space for improvement, but as far as of now, that's what we have. So this is the image name. Target, this is the target in Koji. Target consists of several packages which are going to be used for building of such image. It has also some comms groups which are saying, hey, for a Docker build, let's use this set of packages. For QCOW image build, let's use this set of packages. Then, of course, you need to have kickstart file, which is saying what's going to be the package set of such image. Such kickstart file may look like just thinking what is safe to show. I think this is production, so 167, for example. So this is how the Kickstarter file is going to look like, and this is saying, hey, this QCOW, was it QCOW? No, Docker. So this Docker image is going to consist of Bash, libc, Linux, Python, blah blah blah, and we don't want libss, upstart, and kernel and firmware packages. And then the image build is Koji, or sorry, the Punji is actually running Koji image build config file. The config file which was generated by Punji. Basically, it's just a transformation of this section. So here it will be image build. This looks quite obsolete to me, actually. And so it's basically going to transform this into any file which we pass to brew image build or Koji image build, and this is going to produce image. Punji is going to gather them from the Koji tasks, so it's going to save tarballs inside eCompose, and that's it. So it's just a matter of configuration. We already know how to do that for quite a long time, actually.
So basically that's how the, for example, Fedora server images are built.
I believe that Fedora is adopting this tooling right now. So they are using actually some huge bash script, but the goal, as I said, is to use the same set of tooling.
Okay.
And I believe that they might actually be using it for running the QCOW images, but it's not the images which are actually going to reach production yet. I know that they had several RFEs regarding the image build, but I believe in next Fedora release definitely. But I don't think it's quite there yet. But as far as our internal products goes, this is how we generate images that we ship right now. Yeah, like yesterday and the day before.
Since you are using Kickstarter, it means that it actually uses Anaconda to...
Exactly. That's how it works. So we have several approaches in Koji how you can actually generate these images. One of them is just use Anaconda inside QCOW image, which will generate some tree structure. You are just going to, create archive from the structure and generate metadata. The other approach is create QCOW image and then run a tool. I think it's directly Docker, which can turn the QCOW image into Docker image. The only problem is that the solution using Docker takes about 1 hour, while the installation and just making tarball, stream the metadata, takes 10 minutes.
Yeah.
So I believe that people actually, the general mood is go towards indirection, which is the QCount transformation into Docker. However, the time spent on single image, which is like 50 or 80 megabytes, 1 hour, this is terrible, it's not worth it yet. But we could be there, I got some promise that in a year or so we could be at 20 minutes, and then it might be actually considerable. Yeah, but you are right. Kickstart means that we are actually using Anaconda. Cool, I think that deserves a scarf. So, any other questions? I believe the gentleman here deserves it as well because he had a lot of activity. You're welcome. So, any other questions?
Okay, maybe I don't understand. I can rebuild from source with this tool.
Oh, no. This is actually just creating repositories and deliverables, but the actual build from source is done in Koji. You can use Koji to rebuild something, and then Punji to create a repository out of RPMs built from the SRPM. So we are thinking about a layer below this tool. But that's what we are doing in one unnamed product or project right now.
But you can use mock instead of Koji.
Exactly, and Koji is using mock. Yep, exactly.
So if you have your own kind of needs to build something in the same way, and Koji's or kind of build systems are too big, I would recommend mock, because it actually pulls down and does everything in a change route, which is always the same.
Exactly.
So the output is much more predictable and dependency-wise as well.
Yeah. I can also recommend it for testing purposes because it's just saving you so much time, and you don't need to have the whole chain of infrastructure on your laptop. The only problem is it shouldn't go into production because it's you could have injected anything. While in Koji you can actually see what was in the build route and everything. But yes, definitely it's the same technology which is actually being used in Koji. It's just being somehow locked.
Maybe one interesting thing about Koji it's basically a time machine.
Yep, that's what I told you.
It stores everything and never deletes any single date.
Oh, instead.
So you can go back
Scratch.
and later cut through the database and see how everything looked at a certain time.
So let me show you such example actually.
But it is difficult to install.
No. If you use the how was it called, Docker Dojo or Koji Dojo or Kojak, it takes few minutes. It's out of the box basically, and
But RPM Fusion is still using something old based on CVS, right?
whoa, I don't know. I don't really know about RPM Fusion. Yeah, that's their problem exactly. So
Many people from Fedora are using it, so it's also a problem of users of Fedora.
Well, RPM Fusion is not affiliated with the Fedora in a formal way. It's a
yeah.
separate repository.
So
It's the remote, it's the repo.
So let me just show you the use case of the database. I believe that it should have an option to actually show also the events, right? This is the task ID. But basically, if you would like to, so let's do this. History, help, let's turn events, and you want to build. No. Where am I? Here. Build, and you would like to see when exactly was this build, and what was in the build route. It's super simple. Build. No address. Oh, yeah. Damn, I'm sharing so many secrets here. So here, so it was tagged here, but this is not exactly the build time. But if you will check actually, like brew list, Koji list packages, or list builds, or list tagged, you can set actually, if you will look at the build, you can see the target that it was built against, which in this case was Fedora 23 candidate, and you can actually see that this is the actual build route build, and you can specify the event tag. Oh yeah, you can actually specify the event, I believe, which is the event of the build time. Tagged into testing updates. Untagged. You can use, for example, this event, and that will give you the exact content of the. Yeah, you want the inherit as well. Inherit and latest as far as this event goes. And that will show you the whole build route, all the RPMs that were available at the build time of that package in that certain moment, which is really cool. It's just going to take quite long. So what I consider really nice here, Koji, finally, list tag inheritance. If you would like to see how the structure of repositories goes, then you can see that Fedora 23 build environment is inheriting basically from Fedora 22 updates. This is inheriting from there, and it goes back to Fedora 18. So this is quite nice. You can create quite same for the actual tag web builds. You can create such structures if you have multiple products. Let's say my product is going to be, I don't know, HTTPD, like some web server. You might actually want to inherit from either Fedora or CentOS, the packages which are actually used for building that. You can add some more in your own tag, which is really nice, and you can just reuse all the bits that you want. There are some certain configurations which might allow you to prevent inheriting from certain tags, like, hey, I'm working on, let's call my tag development, and I want to prevent any production product to use my bits, so I can set I can actually tweak policy to prevent inheriting from such tags, which, for example, have development in the name or something. You know, there are several conditions, and you have to think of so many scenarios how to prevent actually the actual user from consuming your data. But it offers you variety of rules that you can use.
Show how the Koji build this event.
How it builds the event?
No.
Oh, yeah, sure. Oh, yeah, sure. So I think that we are basically done here. If you will wait for probably till the rest of the presentation, but it's going to be 12,000 plus packages. You know, so huge.
What is actually also saying is that you can take a build and you can actually extract from Koji exactly which RPMs was installed in that build.
Yep.
So you can actually compare later on two different builds if the build would actually change.
Yeah, this is just like end of the presentation. I basically showed you the Pagure, the GitHub, so you know where to look for the bits, you know where to report issues, you've seen how to report the issues. Yeah, so if you guys would like to play with it in your company, consider starting with Koji. Check the Koji dojo, that will help you if you are into Docker. If not, check Kojak. It's called Koji out of box. GitHub, Kojak. Koji in a box. I believe it works with Fedora 22, it works with RHEL 7, works with RHEL 6. Just run it. There is option install, create VM, or create Docker. So you can install it locally inside the VM or in Docker image. should be quite simple. Authentication is done through certificates or Kerberos or password. Take your pick. So I guess this is all from me. Thanks. Yeah.
Please keep in mind that you can rate this talk on the website, and we are still looking for the writing talks, so you can propose your own if you want, or vote for the existing one. Thank you.
Yeah, thanks a lot. Wow. Máme tady někde koš? To nevadí. Pohod, dokumenty ode mě máš, že? Jo. Haha, máš to zpravovat. Ne, já jsem, ten issue jsem už našel, ale dřív
Tam jsou ve skutečnosti dva problémy. Jednak tím, že skipneš všechny fáze, kromě create ISO, tak se nevygenerují checksamy, protože jsou v samostatné fázi.
A víš, co jsem zjistil? Že když něco takového odstraníš, tak ono by se to posílalo stejně vložit nový záznam do toho image manifestu. To tam nemáme ošetřený.
Jo, tohle jako není vůbec
Ale
testované.
proto je tam to dangerous.
Jo. Včetně té IP. Ještě bych chyběl, jestli měl dodat.
Tyjo, to je tak krásně teplý teďko. Má na to peníze, co bude. Ne, přemýšlel jsem, že by na něco šel. Čau. Ale kočka doma, nevím, na co bys šel ty? Dneska prezentaci nemáš, že?
Ne, to máš zítra. Právě dneska je to
To se chci jít do města, tak jít neřeknu, ale jdu teď asi
nechci.
A možná bych dal někde oběd, ale to možná i s mou kočkou. Promiň, to je moje nebo tvoje, nevíš? Is it yours or mine? I think it was mine, actually. I just
It's not mine, definitely not.
So yeah,
Hey, good morning.
Good morning as well. Yeah, you can prepare it.
Yeah.
Yeah, a few things you should know. I noticed that there are two names for this talk, right?
Sorry, say it again?
I noticed that there are two names for this talk. Is it right or not?
Yeah, I do it and a colleague of mine is actually doing it.
Okay. So yeah.
So he is probably joining now in a couple of minutes as well.
We're gonna go. Last week we wanna ask to interview you somehow.
No, we can.
Something called
Well, actually, this is the second part of the workshop. We already had the first part yesterday, and probably most of the people who come in today have already been there yesterday, so I don't think there was any introduction necessary.
Okay, great. So you already know that you can give them some slot for the questions. So basically, if you then arrange that for you, you can encourage them to ask the questions. And what else? That's
Oops. Sorry.
would it be possible to ask you to put your presentation on the stick? So
I already did yesterday.
So it should be there.
Yeah.
Okay, cool. And other than that, we should give you one more.
One more? Okay,
Yeah.
give me one more.
You have to go.
Can I use it to get some guests to the party tonight? Or do they need this badge here?
This badge,
Okay.
or you can ask the easy photo at the hiding spot.
Uh-huh.
You will have some free tickets.
Okay.
And
You guys are doing a workshop in here?
Yes.
Okay, I'm gonna leave you with some USBs.
you already have some.
I know, but there was some.
And we can do replicate the new version which provide us colleague before. So
Okay.
should be used.
Yeah.
No, only if you need them. It's
No.
it's
So
reserved.
if we have the one from yesterday,
just keep them.
Someone just dropped out
Yeah,
a new version this morning. So can you just
Yeah.
check that that's the current
Yeah,
version?
so just if you don't need them, don't touch them. Hang out. Thanks.
So they just replicated to all those flash drives.
okay, let me.
You can double check that it's the current version. So.
Bylo tam krátké srovnání, jak rychle jakože technologie vyvíjí. Byla tam prostě nějaká fotka jednou z takového, z té lidi, si dělal nějakou památku, ale jeden člověk tam měl takovou fotku teďka o 8 let později všichni měli mobily, takže ničemu, prostě to je fakt. A ukazoval tam taky fakt, jako, že největší provider informace na světě, jakože nevytváří žádný content, největší prodejce nevlastní žádné prostě zboží a takové věci. Technologie na to vlivňují.
Yeah, looks okay.
Okay, great. To je jak to vypadá, viď?
Zvu to říkal předtím.
Can you just send me your name so I pronounce it correctly?
Yeah, should I write it down for you?
Yeah.
So this here. Is that okay?
Sorry?
Be behind here? Okay, I will put it here, okay. So, share. Okay, SCHER. But it's also on the slide deck. E. Yeah, so ER, yeah, ERF.
ERF.
Yeah.
And
But as I
the
said, it's also on
pronunciation
the
is Torsten Schreier?
share.
Share?
Yeah,
Share.
exactly. Sorry. Well, I don't know if everybody still has the keys from yesterday or if they gave them away. Yeah, but well, probably everybody who was there yesterday already copied the content over to their local machine. So there was actually no need to give them the updated USB sticks. So yeah, only if somebody is showing up who was not there yesterday, then of course they need it. But otherwise it's not required. Hey, Mario. Hey, how are you? So, say it again? Yes. Yeah, that does not work. So, did you get the USB stick? I can give you a stick and then you have content available and you can copy it over. I need one USB stick. Okay. Thank you. So when you want it, there's a workshop folder and underneath there's a free IPA folder. So
tím pracuje dobře s ním.
Já jsem to nemůžu do masky, nemůžu do masky.
Že si myslím pracuje, že jsem co najde.
Okay, yeah, that's a bit tricky because this is already the second part, and what we did yesterday is to prepare the whole environment. I mean, you can try to do it today. It's so what you need actually is yeah, it definitely works. But what you need is in the morning you need to set up a data and then so it's all the development element there, and then you yeah, it's on the USB stick. I give you one and then you can try it out.
Company.